Good afternoon, friends. So today we will start the second unit. Am I audible to all? Am I audible to all? Am I audible to all?
Yes, sir.
Okay.
Yes, sir.
So today we will start the second unit, that is classification in ML. So classification, how this task is achieved in machine learning, that we are going to learn. So as a part of first topic, we will discuss on the binary and the multi-class classification. So these are the two different types of classification. So for this unit, you can have the textbook or the reference books, which is mentioned in this slide. So you will find all the topics of this unit in the Peter Flash as well as in the Bishops and Duda. That is the pattern classification, the name of book. So let us start. So what is classification? So classification is basically a task in which we need to learn an appropriate classifier from training data. So classifier, what I mean, a machine learning model which is built using training data set and the machine learning algorithm. So there are many different types of classifiers exist. So there are linear classifier, Bayesian classifier, and the distance-based classifier. So these are some different types of classifier. Classification is just one kind of possible task for which we build or we learn the model. Before we start, what is the classification? Let's have some look on the fundamentals of classification. So what are the parameters or the entities that are required? Okay. So a very important part of any machine learning process is the data samples, or the what we can call it as the instance space. So what is instance? So instance are the objects of interest in machine learning, and they are usually referred as the instances. Okay. Then the group of instances, the possible group of instances will be called as a input instance space. For example, I have suppose, let's say that these are the 6 instances, okay, in my training data set. So these 6 instances, they form this input instance space. So this is what we can call it as the input instance space. Okay. Then each instance in this input instance space, it is labeled. If you observe, I have labeled this instances. So these 3 instances, they have been labeled with the positive sign. What it means? They belong to a positive class. Whereas these 3 instances, they are negatively signed. So it means that they belong to negative class. Okay. So each instance in this input instance space, it is labeled. So these 3 instances are labeled with the positive sign, and these 3 instances, they are labeled with the negative sign. So label space is always represented as L. So the possible set of group of instances, or a possible set of instances, is called as input instance space, which is always represented by X, wherein your output space is represented by this symbol Y. Now output space, it takes different class or different values. Now in this case, in this example, the Y has 2 types of values. One is positive and other is negative. So that means Y is further classified as into 2 classes. So one is positive class and other is negative class. We know that in supervised machine learning tasks, the label space is used to label the examples. So for instance, in classification, the output space is a set of classes which I just mentioned, while in regression, it is the set of real number. Now, as this is a classification task, so here the output space is basically a set of classes. So we have how many set of classes? We have two set of classes, 1 and 0. So 1 represents positive and 0 represents negative. Okay, and this is the output space, which is represented using Y. So in order to learn such machine learning model which performs the classification, we require a training set which is represented by using this notation T to the subscript R. And all the instances of this training data set, they are actually labeled. Okay, and they are also called as the labeled example. So what this means then? So this is basically called as a labeling function. So in the bracket, in the opening and closing parentheses, x comma I of x. Okay, so this I of x, it actually represents the labeling function. Okay, which labels this input instance space x. So I would say that. So I, it may be instance number 1, 2, 3, 4, 5, 6, and so on up to n. Okay, so what is I of x? I of x is basically a labeling function. Now, this is the fact of the matter for the trained data set. Now, the trained data set is the data set in which the labels of our instances are known to us. The true labels of the instances are known to us. Now, what is our objective in machine learning? We are building an approximation function or a prediction function which is represented here, okay, which is represented by I cap. So I cap x tends to L, what it do? So I cap x tends to L, it predicts. This is basically a function which is built by our machine learning model, which predicts the class of each instances. So it predicts the class of x1 instance, x2, x3, x4, x5, and then xn. Okay, and this function, which is only known through the labels it assigns to the training data. Okay, because we know that the machine learning model that we build using trained data set. Okay, so as a part of as an output of this entire process, what we get is the machine learning model. That is, we are extracting the features, then using trained data set, then we are using machine learning algorithm, and we are building the machine learning model. So as we know that there are trained data set we use in machine learning model. At the same time, we also use another instance of the original data set, which is actually not used to build the machine learning model, which is called as the test data set. So test data set is always represented with E. Now this equation, which I have kept it in a box, it represents a test data set of a positive examples. Okay, so how it is mathematically represented? It is represented as x is xi, it may be any instance from x1 to xn, L of x determinant, x belongs to test data set, L of x is again a labeling function, is equal to positive. And the same way, the test data set for the negative example will be mathematically represented with this equation. So TE to the power minus, it represents the test data set of a negative example, whereas T to the power plus this sign, it represents the test data set for the positive examples. So in the beginning, we have seen that the name of this topic is the binary classification and multi-class classification. So first we try to see the binary class classification. So there are two-step process. First, we construct a binary classifier and then we assess the performance of binary classifier. So what is classification? How do we construct the classifier? So classification is the most common task in the machine learning, whereas the classifier or the machine learning model that we construct is, as I already mentioned, it is a mapping function. So this mapping function is represented mathematically here. So C cap is basically a mapping function or my machine learning model, which I represented here mathematically. So C cap, so mapping function for X represents what? X is my input instance space. Belongs to L. L means what? It is the label of the output space. It may be C1, it may be C2, or it may be CK, where labels are C1, C2, C3 up to CK. So I may have 3 classes, I may have 2 classes as a part of my output space, or I may have K classes as a part of my output space. Okay, that is why. But remember, this output space is always finite, and it is usually a small set of class labels. That is ideal actually. So learning a classifier, it involves constructing the function CCAP such that it matches C as closely as possible. Now C is what? C is my actual class of the label Xi. Okay, so that is what. So C, it represents the actual class of my label Xi, whereas C cap Xi, it represents the prediction of my classifier for the ith instance and its label. So what is the label of ith instance predicted by my machine learning model or by the classifier? Whereas C is what? The C is the actual class or the true class of the ith instance, which we have taken it from the training data set. Remember, in the beginning I have just mentioned, train data set has the labels. Okay, all the instances in the training data set, they have the labels or the output labels more specifically. So in the simplest case, as a part of binary classification, we have only 2 classes which are usually referred as positive class and the negative class. So positive class, it can be indicated with 1, and negative class, it can be indicated by 0, or it can be indicated by -1. So binary, the word itself represents that 2. Uni means 1. So when I say binary classification, that means the classification of 2 classes. Okay, in binary classification, the output variable, that is y, the y always takes 2 values or 2 classes. Okay, so let's try to understand this binary classification using this simple example. We have started learning machine learning using this email classification example. So classification of email, the new email as spam or ham. Ham means not spam. So this is basically a 2-class classification, and it is often referred as or known as binary classification. So we are classifying a new email as spam class or to the ham class. So on the left of this figure, it represents the feature tree with the training set class distribution in the leaves, whereas the right figure or the right decision tree, it is obtained using the majority class decision rule. So majority class classification and minority class classification, these are the 2 concepts, so that I will discuss along with the assessing the classification performance subtopic under this binary classification. Okay, so as a part of this figure, you can see that we have chosen 2 words or the 2 features, and that we are going to look into our every new email. So this is the first word is the Viagra, and the second word is the lottery. So if I found these 2 words in an email, then I will classify that email as the spam email. Otherwise, I will not classify it as a spam or ham. I will classify the given email to ham. Then we have seen that the email, if it contains word Viagra, then there are such 25 emails. Okay, we have classified them. Out of these 25 emails, 20 have been classified to spam, and remaining 5 have been classified to ham. Remember, these 25 emails, they have consist this word, and out of this 25, 20 have been classified to spam, and the remaining 5 have been classified to ham. Then we have got another word, lottery. For this word, we have total 75 emails. Out of these 75 emails, there are 60 emails which does not consider the word lottery, and there are 15 emails which consist the word lottery. Okay. Then we found that out of these 60 emails which does not contain these lottery words, out of the 60, the 20 have been classified to spam and the remaining 40 have been classified to ham. And the 15 emails which consist this word lottery, which out of this 15 emails, the 10 emails have been classified to 10 spam category, and the remaining 5 emails have been classified to ham category. Okay, so now I just want to know what is the performance of my classifier. So this is this decision tree which is represented here, which performs this classification. I want to assess the quality of this decision tree, right? Because somehow if I get the better accuracy, if I get the best accuracy, I'm going to deploy this machine learning model, or I'm going to deploy this decision tree for some real life application. Okay, so before I deploy this, I should have to check its quality, I should have to check its performance or the accuracy of the model for the unseen data. Okay, and this is the point where we need to look in the second subtopic called as the assessing the classification performance of your classifier. Okay, so now the classification's performance is assessed by using the concept called as confusion matrix, or it is also called as the contingency matrix. Okay, so you can find it here. This is represented with this example. So in this table, each row, it refers to the actual classes recorded for the instances in the test data set, and each column, it represents the classes predicted by the classifier. So what this means, there are total 50 instances which belongs to positive class, whereas there are another 50 instances which belongs to negative class. So this is the row. This is how we can interpret the row of this confusion matrix. Now let us interpret the columns. So the first column is the prediction of your classifier for the positive class, and the second column represents the prediction of classifier for the negative class. Okay, now we'll try to interpret this example in the upcoming slides. So now we try to find out the accuracy of this confusion matrix, from the accuracy from this confusion matrix. So that gives me how my classifier performs, whether it performs better, best, or it performs badly. So thus the accuracy over a test set T, it is defined as, so accuracy of the test set, it is defined as 1 upon TE, all the training instances. So X belong to I, that means Xi, the first test instance, second test instance, up to N. So TE is basically the last instance in the test data set. So we take a summation of all these things. So let us say that Xi is 1. So I C cap of Xi, that is the predicted class of the first instance X1 and the actual class of the instance X1. If they are equal, then we can say that the instance X1 is correctly classified. If the predicted class of the instance X1, let's say that it is 0 and the actual class of the X1 is 1, then we can say that there is a misclassification of the instance X1 by our classifier CCAP. So CCAP represents what? This is a function, this is a mapping function, and it represents my classifier, it represents my machine learning model. Okay, same is the case. Let's say that if let's take another example, X2 is the second instance that we took, and let's say that C cap of X, it represents the predicted class of the X2 is 1 and the actual class of the X2 is also 1. Then in that case, it is a correct classification. Okay. So in this case, it is convenient way to count the number of test instances that are classified correctly by the classifier. That is, the estimated class label C cap of X is equal to the true class label C of X. So C of X is my true class label and C cap of X is my predicted class label, or you can refer it as a estimated class label. So now alternatively, we can also calculate the error rate as the proportion of incorrectly classified instances. So clearly the accuracy and error rate, they are actually the average or they are the sum to 1. Okay. So error rate and accuracy plus error rate is always equal to 1. So the test set accuracy, it can be seen as an estimate of the probability that an arbitrary instance X belong to X is classified correctly. More precisely, it estimates the probability. Okay, so this probability function which actually predicts the class of some input instance Xi to C of Xi. Okay. Am I audible? Am I audible to everyone?
Yes, sir.
Actually, my battery of the laptop, yes. The battery of my laptop was discharged. That's the reason I was disconnected for a while. So let us go back and give me just 5 minutes. And I know that we are running late. So within 5 minutes, I will finish my presentation. Because this is really an important topic from your INSEM exam perspective, right? There will be definitely a question of 5 or 6 marks based on this assessing classification performance. It may be asked on binary classification or multi-class classification. एक तो example आने वाला है इस पे. Okay, so just give me a 5 minutes. I know you have to tolerate for next 5 minutes. So let us start the few of the concepts that we have to brush up as a part of this assessing classification performance. So a good way to think of this is to remember that the positive and negative, it refers to the classifier's prediction, whereas true and false, it refers to whether the prediction is correct or not. So that's how we supposed to interpret this confusion matrix. So a false positive is something that was incorrectly predicted as positive and therefore an actual negative. Okay, so it is actually a negative instance, but false positive is something that was incorrectly predicted as positive. For example, a ham email which is misclassified as spam. So basically the actual class of the email is ham, but classifier's prediction is spam. So it is, that means there is an incorrect classification or the misclassification of instances. Same is the case, and you just imagine that if the application that we are dealing with, if it is very sensitive like a medical applications, and here you can see that if a healthy patient is misclassified as having a disease, then we can say that it's really a damaging part. Okay, or the performance of classifier is hampers. So we are trying to see this with some of the examples. So a true positive rate and true negative rate, then false positive rate and the false negative rate. These are some examples that we are going to we are going to learn as a part of this topic. So just give me some moment, I will finish this and then we will start. So as a part of assessing the classification performance, what we are going to learn is true positive rate, next true negative rate, then false negative rate and false positive rate. Apart from this, we are also going to learn the accuracy and error rate, as well as we will also see what is how to calculate the F1 score for your confusion matrix, as well as how to calculate the precision of your class. Okay, so this is what we are going to learn in this. So let me quickly go to this matrix which I have plotted at the bottom of this presentation. Okay, so this is basically what we call it as a confusion matrix. So the row, it represents the actual class, and the column, it represents the prediction of the classifier. So now let's say that my positive class, I have total 100 instances. I have splitted this 100 instances into two groups. 50 instances belongs to positive class and remaining 50 instances, they belong to negative class. So what this figure says, that these 50 instances, they are positive instances actually. They belongs to this class positive. Whereas this negative class. Now what is the prediction of my classifier? Out of these 50 positive instances, my classifier, it has predicted 20 instances as positive and remaining 30 instances as negative. The same way, out of these 50 negative instances, the 40 instances have been correctly classified by the classifier as a negative instances, and remaining 10 instances, they have been classified as positive. Okay, so this is what we are actually trying to interpret from this confusion matrix. So the correct classification of positive instances by the classifier is called as TP, which is abbreviated as true positive. Okay, then the incorrectly classified negative instances, okay, that means these 30 instances, they are actually belongs to which class? They are belong to positive class, but my classifier has classified it as a negative class. So they are called as false negative. Okay, they are basically positive, but classifier has classified it as a negative class instances. Same is the case here. out of these 50 negative instances, 40 negative instances have been correctly classified by the classifier, and hence it is represented as Tn. So Tn is abbreviated as true negative. Whereas the remaining 10 instances from the negative class, they have been classified as positive, and that's the reason it is abbreviated as false positive. Do you understand this? Do you understood this? Anyone can answer? Unmute your mic and please tell me. Anyone can tell me whether you understood or not. Shall I stop? If it's heavy for you, then I will stop. I will take it. I will repeat this part in the next lecture. Anyone can unmute and please tell me. I think everyone's device is only on. Nobody is actually active. Is it like this?
No, sir.
No, sir.
So shall I stop?
No, sir.
Vedant?
Yes, sir. Yes, sir. Yes.
So I should stop. What do you mean?
Means, means actually I'm not getting anything.
I can understand since morning you are attending the lectures. So yes, right. So I will repeat this assessing classification performance part in the next lecture. No
Yes,
problem.
sir.
So you can end this meeting. No problem.
Thank you, sir.